Hello everybody, welcome to my talk about our paper POSNoise, an effective countermeasure against topic biases in authorship analysis. Before we start, a few words about myself. My name is Lukas Graner and I'm a research assistant at the Fraunhofer Institute in Darmstadt, Germany. My research interest is, among others, digital text forensics, which can be understood as a generic term for a number of disciplines, focusing on identifying information about authors and anonymous documents. An important and central question digital text forensic is dealing with for a long time is how to determine whether two documents were written by one and the same author. The subfield dealing with this problem is called Authorship Verification, or in short, AV. AV can be used for a wide range of applications, such as ghostwriting detection, continuous authentication, multiple account detection, de-anonymization of thread letters, and a lot more. With the steadily increasing number of research activities in the field of AV, a variety of approaches have been proposed to solve the AV problem, many of which show promising results. However, when taking a closer look, one can see that a large number of these AV approaches rely on features in the text that are not always related to the writing style. One example for such features are character engrams, which represent overlapping strings that are obtained by sliding a window of size n over the text, as can be seen here from the example. Character engrams are among the most frequently used features in AV. However, there's an issue with these features. Since they are extracted from text implicitly, that means in an uncontrolled manner, they capture various text units that, besides writing style, also cover other document properties, such as topic, genre, structure, sentiment, or more. We denote AV methods that make use of such features by the term implicit AV method. Since in an AV task the focus is on the writing style, using implicit AV methods can be problematic, as their decisions may rely on the other aforementioned properties, for example, topic. This raises the question of whether implicit AV methods actually serve their real purpose. In the worst case, such AV methods may degenerate from a style to a simple topic classifier. One way to counteract this problem is to preprocess the given documents in such a way that all non-stylistically relevant text units are masked out. This in turn deprives implicit AV methods of making predictions that can be justified by such non-relevant features. Such a masking approach, which we call text distortion, has been proposed by Stamatatos. Text distortion masks topic-related text units with uniform characters. More precisely, non-frequent words and numbers are replaced by asterisks and hashtags respectively. In order to determine if a word is considered infrequent, a simple lookup in the word list is made. This list, which we refer to as WK, comprises the K most frequent words of a language. For English, the first 15 words are listed here on the right. Text distortion is a simple approach without the need for specific NLP tools or further linguistic resources. However, it has two disadvantages. First, K acts as a hyperparameter and must be specified carefully, regulating how much content will remain in the text. And second, useful stylistic information associated with substituted words may be lost. To tackle the aforementioned issues, we propose an alternative topic masking technique called POSNoise. Our technique not only preserves explicit stylistically relevant words and phrases, but also replaces topic-related text units with their corresponding post-tags. POSNoise relies on two lists, where the first one we refer to as L. L comprises different categories of function words, phrases, contractions, generic adverbs, and empty verbs, which all should be retained in the given text. All considered categories, as well as some examples, are shown here in the table. It should be highlighted that topic-related nouns, pronouns, verbs, adverbs, and adjectives are not present in the list. The second list is referred to as S. This list comprises post tags that, according to the literature, are more related with the topic and content of documents and therefore should be masked. As can be seen from the examples, the considered post tags in the list cover, for example, proper nouns, which are not related to the writing style. Pay attention that punctuation marks and interjections, such as yes, okay, or hey, are not present in the list, since they represent personal and thus idiosyncratic stylistic features. To show how POSNoise works, let's illustrate it with the following example sentence here shown on the top, which will reside in the string shown at the bottom. Here the 6 words understand, destroy, stability, trouble, ordinary and people have all been substituted by their respective post-text symbols. Now let's have a look at the inner steps of POSNoise. As a first step, the sentence is tokenized. Regarding these tokens, we then mark all those that are included in our list L, here highlighted in green. These will be retained in the final output. Note that the list lookup is performed case insensitive, while the original letter case is retained, such as for the I in the beginning. Third, we apply a post tagger to each token. For this, we use the Spaces integrated post tagger. Of the tokens which were not marked in the previous step, we will now substitute all tokens whose corresponding post tags are included in the list S. The substitution is performed with the post tag symbols according to the mapping shown on the bottom right. Note that the substitution are all single characters in order to be better differentiated from regular text units by AV methods operating on character representations of texts. For example, the token understand, which is a verb and thus part of S, is substituted by the verb post tag symbol /O. To allow a reasonable comparison between POSNoise and text distortion, a suitable and fixed configuration for the latter is necessary. However, finding a suitable value for k can be seen as a problematic trade-off, since a low value suppresses too many style-related tokens, while in contrast a higher value leaves many topic-related tokens unmasked. So, our goal is to determine an appropriate k such that first, topic-related words are suppressed, and second, stylistically relevant patterns are retained as much as possible. To select a k value for our experiments, we pursued the following systematic approach. For any value of k up to 1000, we divided the list wk, that is the top k frequent words of a language, into 2 sets. First, style-related entries comprising conjunctions, determiners, prepositions, etc., here denoted as wks. And second, topic-related entries such as nouns, verbs, or adjectives, here referred to as wkt. For this distinction, we made use of our previously introduced list L, which contains stylistically relevant words and thus reflects WKS. On the right, we visualized each value of k up to 1000 against the size of those 2 sets. It can be seen that the style-related curve here in blue increases but is flattening more and more with increasing k. Meanwhile, the red topic-related curve starts off slowly approaching a constant slope of 1. In other words, as k increases, fewer style-related entries occur in WK, while at the same time a higher number of topic-related entries are present. As a resulting k, we select 170, which hereby represents the value of which the style-related entries outnumber the topic-related entries the most in terms of absolute frequency. Based on this value, we examine the extent to which the 2 topic mask representations generated by POSNoise and text distortion differ from each other. Let us first compare the outputs for several example sentences taken from the documents in our test corpora, listed here in the table. As can be seen, both approaches mask topic-related words. However, in contrast to text distortion, our approach retains a greater number of style-related patterns, including contractions such as "id", multi-word expressions such as an example, or sentence openers such as therefore. In contrast, there are also a few words that are retained by text distortion, which are considered topic influenced by POSNoise, and thus are masked, such as the word people. Another difference that can be seen is that POSNoise not only retains stylistically relevant phrases, but also generates additional features. In this case, post tags that increase the diversity on the document's feature space. Such feature compositions can play a decisive role in the predictions of an AV method and are therefore desirable. To evaluate our approach, we compiled 7 English AV corpora and selected 6 well-known AV methods that have shown their potential in various studies and published papers. The corpora cover a variety of challenges, such as texts of authors written in different time periods, texts with an excessive use of slang, or texts with no cohesion. Note that all corpora are balanced, meaning the amount of same author verification cases equals the amount of different author verification cases. Furthermore, each corpus was partitioned in author-disjunct training and test partitions, covering 40% and 60% of the original corpus respectively. Of our chosen methods, all are based on implicit feature categories and are thus susceptible to topic influences. The first 4 rely on character engrams, while the other 2 are based on frequent words and tokens. We applied all methods to each corpus by training on the training partition and then evaluating on the test partition, measuring accuracy and ROC AOC. Note that for each corpus there are 3 versions: the original, the POSNoise masked, and lastly the text distortion masked version. A closer look at our results shows that POSNoise outperforms text distortion in terms of accuracy and AOC in 81% and 76% respectively. Of all AV methods, co-off and unmasking benefit the most from the topic masking of POSNoise, leading to about 10% improvement in terms of accuracy and AOC. Furthermore, it is also noteworthy that for any value of k, meaning up to 1000, text distortion performs worse or equal to POSNoise in terms of median accuracy. Besides our previously selected k value of 170, we further evaluated text distortion with the settings 100, 300, 500 and 1000. In this respect, a closer look at the results reveals that text distortion leads to higher accuracies the more k increases. In most of the cases, the highest results were obtained when using the original corpus, which can be seen as applying text distortion with a maximum possible k value. However, what is not reflected by simply measuring the accuracy or ROC AOC is at what prices these improvements occur. We want to clarify that the goal of our masking approach is to primarily ensure that AV method decisions are based solely on stylistically relevant features. To gain a better understanding of how higher settings for k affect the performance of AV methods, we first show how much topic-related text units remain in the documents preprocessed by text distortion. First, we concatenated all documents in each corpus and applied text distortion with various k settings. Next, we subtracted from the resulting tokens all that appear in our list L. The remaining words are then highlighted in the word clouds illustrated here, where more frequent tokens are shown larger. The asterisk here is the largest, since it reflects all tokens which are masked by text distortion. As can be seen, the document representations retain a wide variety of topic-related words. The greater k increases. Examples are people, system, data, and information, to name a few. All these are not retained by POSNoise. The presence of these topic-related text units provides a first indication that the improvement in verification results may be attributed to them. To investigate this further, we proceed on the basis of the following assumption. If more topic-related text units remain in the texts, this should be reflected in the context of a topic classification with correspondingly higher results. For this, we selected 3 well-known topic classification corpora, namely AG News, Yahoo Answers, and BBC News. Next, as our topic classifier, we selected standard logistic regression, which uses token frequencies as input features. It was then trained and evaluated on each corpus based on a 5-fold cross-validation. We visualized in the scatter plots the median AV accuracy of the 6 methods and 7 AV corpora against the cross-validated topic classification accuracy with respect to the applied masking technique. The ideal case for a masking technique is in the bottom right, resulting in a perfect AV accuracy and at the same time random topic classification accuracy. This would reflect one that retains full information of writing style while eliminating any topic signal. As can be seen, for increasing k, text distortion leads to higher AV classification results, but at the same time also to higher topic classification results. In contrast, POSNoise approaches more closely the best possible compromise between topic and style. When comparing POSNoise in the original form, one can further observe that for the latter, the topic signal is much stronger, as the topic classification accuracy is significantly higher, up to 35%. This shows that POSNoise leads to a substantial reduction of topic-related text units without strongly affecting the style-related classification performance. Separately, one can see from the scatter plots that regarding text distortion, the setting k equals 170 in fact represents a good compromise between topic and style. As compared to a value of 100 or 300, it pushes further to the bottom right direction. It should be noted that for these 3 corpora, the function words alone already represent a strong classification signal for the topic classification, since applying the topic classifier on function words only yields results comparable to text distortion with a k value of 100, such as a topic accuracy of almost 70% for the BBC corpus. So, to wrap up the talk, I would like to summarize the following observations. Topic indeed distorts results of AV methods. Topic masking can lead to better results due to canonization. This is especially the case when strong topical variance is present in the documents. However, it may also reduce the detection accuracies of AV methods, particularly implicit methods, for example when topical biases are present in the data. In this context, it is important to emphasize that the lower performance with respect to POSNoise marked Cobra should not be inherently regarded as negative. In an authorship verification task, a certain degree of accuracy could and should be exchanged for the fulfillment of the true objective, which is classifying documents by the writing style rather than their topic or content. Besides the benefits of our approach, there are also several issues that require further considerations. When considering languages other than English, POSNoise must be adjusted accordingly. First, a predefined list of topic-agnostic words as well as phrases must be compiled, and second, since our approach relies on a POS tagger, the availability of a trained model for the desired language must be ensured. Furthermore, due to the post-tagging process, applying POSNoise is accompanied by a higher runtime in comparison to the existing text distortion approach. Also, due to the partial dependence on an external post-tagger, its imperfections are inherited. One idea for future work is to investigate automated possibilities to extend the compiled pattern lists. This can be achieved, for example, by using alternative linguistic resources such as lexical databases that are also available in multiple languages, like WordNet variants. Another direction for future work is to investigate the question in which verification scenarios POSNoise is also applicable. One idea is to perform experiments in under cross-domain AV conditions, which often occur in real forensic cases. For example, how a model trained on cooking recipes performs on forum posts for which no training data is available yet. Beyond that, we aim to investigate the suitability of our approach in related disciplines of authorship analysis, such as author clustering. Alright, this is the end of my talk. Thank you very much for watching and listening, and let's start the question session.